In this video, we're going to address acid deposition or acid rain. So it is depositing or deposition of acid or acid-forming pollutants from the atmosphere on the Earth's surface. With ozone depletion, it's a global problem, and we've had some success in solving it. So acid rain is a specific term for acid deposition, but acid deposition can be rainfall, gases, or deposition of dry particles. Acid deposition is one form of atmospheric deposition, which occurs when any solid or liquid material from the atmosphere is dropped onto the Earth. It's caused by fossil fuel combustion, and it spreads far and wide on air currents. So it's a result of burning fossil fuels and releasing sulfur dioxide and nitrogen oxides. Then they react with water and oxygen in the atmosphere and form low pH acids. So we get sulfur dioxide, nitrogen dioxide, water and oxidants mix with it, and we get sulfuric and nitric acid, which in concentration can be very corrosive and damaging to living systems, but also our buildings and other structures. So detrimental effects on ecosystems include leaching of base cations such as calcium, magnesium, sodium, and potassium, which counteract acid deposition from soil, and these are all essential to living tissues to run cell functions. They allow sulfur and nitrogen to accumulate in the soil, and then excess nitrogen can over-fertilize native plants and encourage weeds. And they increase dissolved inorganic aluminum in the soil, and in high concentrations, aluminum can be toxic. And they hinder uptake of water and nutrients in plants. Leached calcium from needles of red spruce, causing trees to die from wintertime freezing. They lose their antifreeze, if you will. Increased mortality of sugar maples due to leaching of base cations from soil and leaves. They've acidified 41% of Adirondack, New York lakes and 50% of New England lakes. They diminish a lake's capacity to neutralize further acids. So they are compromised and they can't address and cleanse other threats. They elevate aluminum levels in surface water, and then reduce species diversity and abundance of aquatic life, affecting entire food webs. So you can see the ecosystem devastation, and then you can also see how they can take older structures and erode stone vehicles, crops, in a way that is, some of these are irreplaceable. So the Clean Air Act of 1990, part of the reason it was amended is to establish the acid rain program to fight acid deposition. And so emissions trading programs for sulfur dioxide, they allocate permits for sulfur dioxide pollution and allow emitters to buy, sell, or trade these advances. So it's kind of like trading cards in the sense that if you have a coal plant, you're going to have a high amount of sulfur dioxide that you're going to emit. But you have a permit for so many. So if you can trade with other industries, then it can reduce overall, but that it can also allow for business to be done in some senses. So this is but it creates a strong economic incentive to reduce emissions, because you get lots of fines or restrictions if you do not meet the standards. So it is effective and important. So the cap and trade program successfully reduced sulfur dioxide emissions in the U.S. by 67%, which is pretty profound. So you can see 16 million tons almost emitted in 1990, and down in 2010, down to 5 million. So we're going to talk about clean coal and with scrubbers in the stacks. That's been a huge part of the issue. Reduction in coal, a lack of availability of coal, switching to things like nuclear or natural gas, but they have other issues. Restrictions on power plants reduce nitrates emissions, which significantly reduce nitrogen deposition. So overall, the pH of precipitation has improved significantly since this law passed. So you can see in the Rust Belt and the East Coast, where the big cities are, we're looking at increasingly acidic pH, and now we're much more into the 5 range, which is still acidic, but better. Okay, in our next video, we're going to talk about indoor air quality.